Okay, let's log in. So I tried the meta spades, no, the spades, which is the assembler, which is our next step. And we won't run it because it's 20 minutes just for one run. And if one of us is running the program, nobody else can do anything at the same time because it's using all the memory and all the CPUs. But I really hope that you will have the chance to do it. So just come back anytime, especially we have a weekend ahead. So you just come back and do what we will do today. I will show you how to run, and I will show you what you will get back. So you can just do the same. If you want, you can do it on your own data or on the same data we are working on. So the spades, well, this is what we don't need anymore. So if we Google Spades and Spades Assembler, because Spades is a lot of other things, for example, a card game, so at least Google for Spades Assembler, then the very first link is the one we have to go to. This is a Russian link, Russian server, St. Petersburg University, and this is the program. And there is a very good manual here actually. So if you really want to go into the details, especially if you want to do assembly with multiple libraries, or if you want to do assembly with Illumina sequencing together with MinION or PacBio sequencing, for example. So if you want to do hybrid assembly, then this is the place where you will get a lot of very interesting, very important, and very easy to understand information. And of course, we have to download as well. So what I will do and what Joe will do with me now is to download the binaries for Linux, but instead of clicking on it, the usual right click and copy link. And we are going back to our home directory where you probably are, but if not, just say cd and the usual wget, paste the file here and run. This is very fast. Again, it's a very small program. And if it works well, then you will have your Spades tar gz there. Again, this is a tar.gz, so which means that we have to uncompress it. So it's tar -xzpf Spades. Again, this is just Joe who has to do this, and me. And then here are all the programs that we can use. There is a lot of small parts, but what we will use is just the main Spades program, which is a Python script. It's actually a Python 2 script. So I also had to install earlier the Python 2.7 programming environment. Okay, so I don't know if we just simply say Spades now, maybe we will get a small help. Let me just try. So if I'm going into Spades and the bin, which is the binary, and just say spades.py, this is the script. Yeah, and we get quite an extensive help, so you can do this as well. And here is the main usage. So we have to say spades.py, and there are a bunch of options, and then you have to give the output directory where you want to have your assembly. So there are subtypes of the spades, which is now in our case it's not important. We don't want to do meta spades, metagenomics, or plasmid assembly. So these are not extremely important. The important things are these ones here. How do you set the input data, and how do you set other pipeline options? So if you only working the very simple pipeline we started building up last time, then what we ended up, let me just show in my other window here, which is bit smaller. So as you remember, our last thing was to use the Flash program to merge the overlapping reads, short reads. So our three output files from that was this out dot not combine 2 and 1 and the extended fracs. So these two are the parent sequencing library files, which were not able to be combined, and these are the merged ones. So this is the three files we will use as an input. If you have multiple libraries, as we discussed last time, if you are using multiple libraries with different insert size, then you can make better assemblies. Or if you have an Oxford nanopore data, or if you have PEG-bio data, then these are all different inputs to the Spades. But if you are just working like this, which is, I think, the default and the most usual way to do the assembly, then you have to do, you have to give only 3 inputs, -1 for the forward parent reads, -2 for the reverse parent reads, and -- merged for the merged forward and reverse parent reads. If you have single reads or unpaired, you can use -s. I don't think there is any difference in our case if we are using -s or -- merged. But I think it's a bit better to use -- merged because they are actually merged. If you, so let's go to our folder. And again, I ask you not to run this, but I will show you the full command. And if you want, you can just hit enter, and then by hitting Command C, you can just interrupt the run. So you will have the full command in your history if you want. But of course, you can also look at the recording to see what is the full command. So if you are in your Scratch directory, then the first thing what we have to do is call the program. The program is of course in our home directory. So you can use 2 different types of path. I don't know if we, I think last time we always used the full path, which means that we always said /home /bioinf, or for me /ubuntu, and then spades, and then bin, and spades.py. This is the long and the absolute path, but you can also use, because you are having these folders in your home directory, the whole home directory. So this here, the /home /ubuntu, can be replaced by this wave thing. That's why I actually also used the wave before when I showed you how can you change the permission on a file in your home directory. So this is, I think it's sooner or later it's much better to start using this wave and /, and this is your home directory. So we are starting with this. We are setting -1, and here we will put in the not combined 1 FASTQ file. The -2 will be the other one, which is again not combined but 2. And we will have the -- merged option, where we will put in the extended fracs. So this is our input. What we also have to give, if we don't give anything else, is the output, the -o and the output directory, which is usually just simply an assembly, or this is my assembly from my run previously. So if you say -o assembly, it doesn't have to be there. If it's not there, it will be created. So it's okay. Sorry that my line is not complete, but we will have even a bit more options here. The next thing what we can give is the k-mers. So this is now much more the pipeline options, or actually the advanced options. You don't really have to, because so the minus k will give the program the size of those k-mers that it uses to look for overlapping reads. And it has an auto checking, which means that it's probably checking the library size first, and then it sets it automatically. So it doesn't have to be set, but if you look at the documentation, search for the k-mer word, I think there is a few suggestions that you can use for an Illumina sequencing. Yeah, so something like this minus k. But it doesn't have to be there, I think. I'm usually using a fairly long, yeah, this one. I usually use this one as the setting. It's actually for much more for ion torrent reads, but also I think it's for good for Illumina as well. We don't, yeah, we have this one. Yeah, it says it can be okay. Let's just leave it automatic. Don't worry about it at the moment now. So we don't have to use the minus k, but what we probably have to use is the minus t. This is the number of threads. So if we are on this laptop or on this server, then the maximum number of CPU cores we can use is 4. But of course, if you are doing it on your HPC or in-house server, you just have to check how many processors you have. The Spades is scaling very well. So if you give 2 times more CPU cores, it will be 2 times faster. Unluckily, the Spades is not able to run on multiple nodes. So if you run program in parallel, you can run it in 2 different ways. You can run it on one physical computer node or computer on a PC and run it on all CPU cores within the PC, or that's option 1, or option 2 is that you are using multiple computers and multiple CPUs. But for using a program in multiple computers at the same time, it has to be written in that form. So the program has to run like that. And the Spades is not able to run like that yet. So minus T4, and usually what I give as well is giving the maximum amount of memory, which is minus M. So it's minus M. Oh yeah, and there is one very, very important option. So minus M, on this computer we have 24 gigabytes of RAM, so 20 I think is okay, and 20 will be enough. I tried with these settings and it was more than enough. And finally, one of the most important thing is using the minus careful option. This was for a very long time, this was I think a very strong suggestion from the Spades guys. And this is actually a mismatch corrector. So it before the whole assembly, it tries to find mismatches and correct them. But there are problems with this. So let me just give you an example from one of our own studies. We found an E. coli with metagenomics. So we built the E. coli together metagenomic sample. The minus careful option, it cannot be used for metagenomic samples because they are too diverse. It can only be used if you are doing the colony sequencing and you have just one genome inside, or a very few genomes with high coverage. And what happened is that somehow there were two genes that were very similar to each other. Actually, they were antimicrobial resistance genes with only a few SNPs difference between them. And for some reason, one of them had a much higher copy number than the other one, like 10 times higher. And it wasn't a problem for the metagenomics assembly because there is no error correction. But when I asked Ibrahim to isolate that E. coli, it was isolated and we sequenced the E. coli, and then I tried the assemble. I assembled the genome from the clone sequencing. I found that I only saw one of these genes, the one which was much higher abundancy, had a much higher abundancy than the other one. So what happened is that probably the higher abundance AMR gene was on a multicopy plasmid, or the lower abundance was on there in just a small subpopulation of the E. coli. I don't know. But what happened is that during this error correction, the Spades saw that, okay, there are very similar sequences with only a few SNPs difference. So what it does, it collects all the short reads that are matching with the same sequence chunk. And when it saw that, okay, there are 30 A's and 5 T's in one position, that's probably a sequencing error, because it knows that it's a prokaryotic prokaryotic genome, that there shouldn't be any heterozygosity. So it's probably, it thought by the program that it's an error. It was just simply excluded. So we lost that other nucleotide from the same position, which means that we lost the other gene. So the two genes together were assembled into one contig, which represented the gene which had a higher abundancy. So be very careful with the careful option, minus careful option. Especially if you are sequencing bacteria where you expect a lot of AMR genes and maybe multiple AMR genes from the very same category. So if there's a chance that they are only different in a few nucleotide positions, then maybe it's better not to use the minus careful, but otherwise use it, because it makes your data much nicer, and it corrects the sequencing errors. If you have a suspicion that you lost something, then you can use because I think in default, maybe the minus careful is enabled, but even if it's not, there is a kind of error correction. So if you just want to do the assembly without error correction, then use the minus only assembler option. And then it will only assemble without doing any error corrections in the beginning. But in most of the cases, it's better to use the minus careful. So that's the whole command. Let me just start running, and I will just interrupt now with Control-C. But yeah, it starts and it's working. And if you run this on your own, then it will run for about 20 minutes. So you can see what is happening. The first thing it starts with is the error correction part, and then it goes with the different k-mers, which yeah, it's the default k-mer what we set. So 21, 33 bases, 55 and 77 bases, which means that it is chopping all the sequence reads into these small k-mers and try to find the ones which are overlapping. So it actually builds up a huge interaction matrix or distance matrix between these sequence reads, and then using something which is called the Bruegin graph. I think it is maybe spelled like this, pronounced like this, to build up the context. I will just go up and show it to you. So the command starts here. So if you are in your own directory and you have your not combined and combined FASTQ files and the extended FASTQ file from as the output of the flash, and this is how you run it. I know that many of you will just get back the assembled FASTA file. So if you send your sequencing, as far as I understand, if you send your sequencing to the Sanger, then you will get back an assembled genome. But I think it's very good to know how you can do it in your own. If you will have a MySeq sequencing, or if you are sending your sequencing to a HiSeq or a NovaSeq, and you get back only your FASTQ files, then this is the way how you get to that point, the same point which you are if you send it to the Sanger. And again, you know much more. So if you just send it to the Sanger, you don't know how your library was, if the library size was okay. You don't know how many reads were merged. You don't know how many reads were excluded because of duplications. I don't know if you get back anything about the if you get back a FASTQC from the Sanger. So looking at the sequencing quality actually. So you actually missing quite a lot if you don't do this yourself. Right. So instead of running the program, and I hope no one is okay, no one is running. Perfect. I will copy the assembly folder to the main Scratch directory, so you can just copy. Actually, I think you will only need one file from that for the further work. So I'm just simply moving my assembly folder to up to one directory, and if you go to the main Scratch directory, not in your but the main Scratch directory, and go into the assembly folder, and this is the thing what you will get back at the end. So it's quite a lot of files, quite a lot of space again. So this is something what you should also remove as soon as you think that the assembly was okay. You just simply remove the whole assembly folder, because all of these Kmer folders are full of files, and there are the corrected FASTQ files, and there are so many things which you will never again open and look into. There are actually two files here you want to see. One is the context FASTA, and the other one is the scaffolds FASTA. I don't really like going with the scaffolds FASTA because it contains n's, and some program is a bit picky for n's, so it cannot really work if you have n's in your sequence. The context is always just composed of ACG and T nucleotides. There's no unknown nucleotides in context FASTA. We can quickly see the difference between them. So the scaffolds FASTA is actually the file where Spades tries to assemble context and say that, okay, contig 1 and then contig 2 and then contig 3 is coming after each other. So if we have, let's see how many contigs we have in the context FASTA. And this is exactly the same data as we were working. So I did this assembly from from the same data we had. Okay, thanks Suresh for copying the comment there. Is it okay now, Rhiannon? You have everything? I hope.
Yes, thank you.
Okay,
thank you.
thanks.
Sorry.
Okay, so if so, one of the first things you may want to see on your context FOSTA file is how many contexts you have. So how much it is fragmented. It's because before we are going into the gold standard quality checks, just a very fast check is how many FOSTA entries you have in your context FOSTA. So how many contexts you have, which can be done with the grep command. So this can be run by anyone again. So you can see my assembly folder. You can see these files. So you can also do what I'm doing. So if you say grep -c, it will only count. It will not put it into your screen. And what we want to count is this sign, because this is the FOSTA header, and we are doing it on the context FOSTA, especially if you are already in the assembly folder. And then you will get back a number, which is quite a high number, so it's quite a fragmented genome. But again, as I told you last time, you don't really need just one chromosome every time. I mean, there are applications when you need, if you really want to see the chromosomal organization, if there are certain species that like to rearrange their whole genome. And if this is an important thing to you, then this is definitely too much, probably, and you won't see the genomic organization of that isolate. But I think this is what you will get back with Illumina short-read sequencing. So if you want to see more, do some tricks, a bigger library or long-read sequencing. And if you want to see how many of these contexts were assembled, so you can do the same on the scaffolds FOSTA. And you can see that a few only, so this is only 14 less. So 14 contexts were merged with something else. So it's not a huge change, or not a huge improvement, actually. So I would like to ask all of you just to copy the context FOSTA into your folder. So go back to your own folder and copy /assembly. So this is one up, assembly, and context FOSTA, and of course a dot at the end, which means that you are copying this file to here, where you are in your own folder. So now you have the context FOSTA in your folder. And now we can go into the details. So what we will do, we will try to run the checkm. I haven't run the checkm, and I have a fear that it will run as well a bit long, but I really want to see the checkm and show you the checkm output. So again, Joe, I have to ask you to help me. Google again. We are looking for checkm. It is one word. And we are not looking for the online database, but we are looking for this GitHub link. So it's, for me, is the second one. Actually, I think it will be the third one, but we will see. I think this is just a basic website for it. Maybe it's the third one. The github.com. Yeah, this is it. Luckily, as far as I remember, there is a conda install again. So if you click on the installation, then there is a, if you use Bioconda, you may find these instructions useful link. And this is a link to a few conda commands. So in this case, as you can see, we will create a special environment for the checkm. So what you see here, instead of just simply saying conda install Python and checkm genome, we are saying conda create -npy27 Python 2.7 anaconda and checkm genome. So what we are doing here is that we are making a separate environment for the whole checkm program, and the checkm will work in that environment perfectly. So the first thing what we have to do, just me and Joe, we are going back to our main directory, to our home directory. Copy this one, but don't run yet, because we don't need the anaconda here. If we do that, it will be much longer and we don't need it. So what we will do is just create an environment called py27 for the checkm, and it will have the Python 2.7 as the default Python programming environment. Why? Okay, we don't have the conda. We installed it last time, but it's not. I think we have to enable the base. We don't have the conda. I'm sure I installed it and reinstalled it as well, but I can imagine that it was deleted. Okay, let me just try to install conda centrally. No, we didn't do it because we didn't need conda. Did we do any installation with conda last time?
We didn't.
Okay, so that's why we don't have. Okay, let me just try to install centrally. If not, then we can. No, okay. Then we will install conda as well. We will install the mini conda. So again, Joe, I ask you just Google for mini conda. And from here, we will install the 3.7. I know that not the Windows, but the Linux installer. So go down to Linux installers, go to the Python 3.7, and go to the 64-bit one. And again, right click and copy link. We will use the 2.7 environment for the checkm, but most of the programs will use 3.7. So that's why I'm installing the 3.7. And within the environment, it will be 2.7, so it's not a problem. Okay, so the Linux installers, Python 3.7, Miniconda Linux 64-bit. Right click, and we are in our home directory, and the usual wget and this. Is everything working for you, Joe?
Yep.
Okay, thank you. Just stop me if there is any problem. So we have this sh program here, which is probably a small shell script, which we want to run. If we want to run, we have to make it executable. So as you can see, there is no X flag on it. So what we will do is just saying ch mod u plus X miniconda, blah, blah, blah. And if you say enter, and you can check, now it is green because it is executable. And we have the executable flag here. And as soon as we have it here, we can just say /miniconda sh. The / means that we are running it from this directory. There will be a Again, this is just me and Joe who is doing this, but of course, if you are installing Conda on your own server, you have to do the same thing. There will be a long user license agreement. What we have to now read together, or not, just push the space a few times until you are at the end and say yes, because of course you are accepting the license terms. From now on, you don't have to write anything, because if you see something in square brackets, that's the default, so you don't have to change the default installation location. Just push enter here, and it will unpack. And it will also ask you if you want to initialize the Miniconda environment, and you have to say yes to this as well. And it's done. Now, for all of us, we have to log out and log in back, because it's not working yet.
Mine says unpacking payload.
Okay, so you are waiting at that point, which was somewhere there.
Oh, and then it says exec format error.
Oh, so you have an error.
Yep.
Hey. Did you get back your console?
Sorry?
Did you get back your command prompt? This one, the bioinf course.
Mm-hmm.
So you can, let's just, I can imagine two things. First thing is that it was maybe downloaded wrongly. Let me just check the size of mine and yours, because maybe there was something with the download. Or just because we do it at the same time. And oh yeah, actually mine is completely different in size. Ah, because you downloaded the Mac OS one.
Oh, yeah.
I think I told you to go down to Linux. Okay, so go down to Linux installers and the Miniconda Linux 64-bit. Just because you are working on a Mac, this became a default download for you, maybe. But yeah, we are needing the 64-bit. Just tell me if you finished with downloading, and
then change mode.
it was U plus X.
Yeah. And what did I do after that?
Yeah, it's now much better. And then just / Miniconda latest Linux. Is it running now?
Oh, God.
Mm-hmm.
What have I done?
You have two different files. If you just up to that point here, Miniconda 3 latest, and then it stops here. Are you looking at my shared screen as well?
Bless you.
Bless you, Ibrahim.
Oh, sorry. I forgot to move.
Luckily, we were just sneezing, so.
Bless you. Should I run that?
Just like the Linux one, like this.
Yep.
It's possible that it doesn't auto-complete the whole thing for you, because you have the Mac OS and the Linux version as well there. So if you try to auto-complete with a tab and you ended up here, because it doesn't know that you want to run the Mac OS or the Linux one, you just have to put another letter like the L, and then autocomplete.
Yeah.
Okay, and yeah, just run. And first you have to go through the license agreement with spaces, and then say yes. And then just pushing enter and enter and enter. And then at the very end, you have to say yes for the conda init.
Was this the change mod u plus x, but for Linux?
Yes, otherwise you cannot run it.
Yeah.
Yeah, so yeah, this one, chmod u plus x.
U plus x. It doesn't like that either. It's not doing anything. Thought I was doing so well.
Okay, so the Linux is there, it is executable. And if you are in your home directory, I mean in the bioinform directory, and say / miniconda3 this thing. And just try to run. What does it say? What?
Yep.
Is it running now?
Yes. Press enter to confirm location.
Yeah. So what you have to do is you have to go through the license agreement just by pushing spaces and then say yes that you are accepting it, and then just push the enter a few times. And when you are here at the very end, do you wish the installer to initialize miniconda3 by running conda init? That's the very last question.
It says error directory already exists.
Okay. Yeah, the Mac started doing something. Okay. So what you have to do is just push Control C if you are not there, and just remove this miniconda3 folder from there. So if you are in the home directory, then say rm -rf miniconda3 and enter. So it was probably initiated by the macOS installer, but it wasn't finished. And the problem is that it's there. And if it's deleted, then rerun the Linux installer. Of course, I won't do this now because I don't want to delete mine.
Yeah, it's running.
Okay. At the very end, you will have this question. Do you wish to install it to initialize miniconda3 by running conda init? And for that, because the default is no, just say yes. And if it's done?
Yep.
Is it done?
It's done.
Thank you for installing. Okay, then all of us, we have to log out. So Control D and log back in again. And the big difference is that we will have this something called base in the very beginning now.